Welcome to Something to Talk About from the Bainbridge Island Senior Community Center. Our programs, Monday, Wednesday, and Friday, are sponsored by Fieldstone Communities of Bainbridge Island. To learn about Fieldstone's memory care or day stay or respite programs, or to take a tour, call this number, 360-689-4314, and take a look at Fieldstone's beautifully appointed apartments on Rolling Bay. I'd also like to mention that we are located on the ancestral homeland of the Coast Salish people, specifically the Suquamish tribe, the people of the clear salt water. We're grateful for their hospitality and we honor them. And today we're going to go aloft. We're going to talk with an old colleague of mine. Well, he's not that old, but back in the day, we used to work together at MSNBC Microsoft. And James Burk is now the executive director of the Mars Society. And he was telling us before we got started that he'd been volunteering there for many years prior to becoming the executive director. Welcome, James.
It's such a pleasure to be here. I'm really thrilled to talk to everyone today about what we do at the Mars Society.
Great. Yes, I know that you had agreed to give us a little overview of the nonprofit organization. And as executive director, you can talk about the current programs and maybe how you all got through COVID and what initiatives are going on right now for the Mars Society.
Absolutely. I'm going to go ahead and share my PowerPoint deck. Can you guys see my slides there?
They're coming up. Yep.
Okay, awesome. So yeah, as Reed mentioned, we used to work together at Microsoft. I worked there for about 20 years as an employee and a contractor. I was a technical project manager and a software engineer. And I'm also part of the Mars Society, and I've been part of the Mars Society since it got started back in 1998. So this is our 25th year of operation as a nonprofit. And we are dedicated to going to Mars. We're the world's largest nonprofit that is focused on the human exploration of Mars and settling Mars as a second home for humanity. And this is our logo. This was a painting that was done by Michael Carroll, an artist that does a lot of space related artwork. And it shows kind of the past, present, and future. We've had rovers going to Mars, and we've had other spacecraft visiting Mars since the 60s. I was really influenced when I was in college in the 1990s by the Mars Pathfinder mission that went there. And you see the small rover called the Sojourner on our logo on the left there. Since then, we've had much bigger rovers that have gone to Mars. Currently, there's the Perseverance and Curiosity rovers are both operating, and they're both about the size of a car. Whereas this small little rover here you see was about the size of a microwave oven, but it was the first explorer on the surface that was able to go traverse around and look at rocks and look at different things.
And boy, there's been a lot of learning in those trips. I mean, it's in the period that the Mars Society has been active, you've managed to sort of get a lot more information about what that planet is and how habitable or how it might be habitable.
Yeah, exactly. When we first got started at the Mars Society, the perception was that Mars was not very hospitable, and there was not any water on Mars, for example. That was the thinking at the time, and since then we've discovered that there's water all over the place. In fact, Mars was once a warm and wet planet like the Earth about 4.5 billion years ago, and why it isn't that way anymore, how it got the way it is now, which is kind of an arid planet that doesn't have a magnetic field and it's very cold. And there's, all the water is kind of locked into the surface as ice underneath the ground. How it got that way is a mystery. And solving that mystery and also looking for life on Mars, which is very possible that there's life on Mars because, like I said, Mars was once a warm and wet planet like the Earth. And around the time that life got going on the Earth, it was Earth-like. And so it could be that, life got going on Mars and migrated here through asteroid impacts, or vice versa. Life could have started on Earth and migrated to Mars in certain around that time frame. And so, searching for microbial life on Mars is a huge scientific priority, we believe, at the Mars Society, and could lead to some fantastic scientific breakthroughs. I mean, just imagine if we were able to find life on another planet, comparing it with life on Earth and seeing what the differences and the similarities were could lead to new pharmaceuticals and medical treatments and all kinds of understanding about, the species on Earth. So for us, that's like a big reason to go to Mars, is to explore it, to look for life. And it's much better to explore a place with human beings than with robots. I mean, would you, if you were going to go to Europe, say you're going to take a vacation to Paris, would you rather go yourself or send a drone to take some photos? Which one would be better? Well, we've been sending drones to other planets to take photos instead of going there ourselves. And wouldn't it be better to explore ourselves with humans? But also, Mars has all the resources. It's kind of surprising. Like, Mars has all the resources you actually would need to build not just human settlement with air and water, but also you can make plastics and electronics, and there's rare earths on Mars. So you have all the things you'd need for high-tech civilization, not just surviving. So that's what we believe at the Mars Society. So that's our goal as a nonprofit, is getting humans on Mars. And we believe we have the technology now to do that. There's never been a mission to Mars. It's a lot harder to do than going to the moon. The moon's only 3 days away, and with chemical propulsion. So the Apollo missions were about 10-day missions, and a mission to Mars would be a much higher order of magnitude. It would be roughly a 3-year trip to go to Mars and back. It takes you about 6 to 9 months to go to Mars, kind of like traveling in an old wooden sailing ship across the Pacific Ocean. You could probably speed that up a little bit if you had nuclear propulsion, nuclear powering an electric, a solar electric propellant. But if you were just using chemical rockets, it'd be about a 6 to 9 month trip. And then you'd spend about a year on the surface, and then you wait for your window to open up so you can come back to Earth. But we believe that that's a mission that's doable. And the Mars Society got started because a man by the name of Robert Zubrin wrote a book called The Case for Mars, and talked about how to do a mission like that cheaply with today's technology. And one of the things that he talked about is a living off the land approach, where you would actually make rocket fuel from the resources on Mars. And the way you would do that is you could take the Martian air, which is mostly carbon dioxide, and react it with a little bit of hydrogen that you either brought with you from Earth or you got out of the water that's on Mars. And then you can, with those two elements, you can make methane, CH4, using something called the Sabatier reaction. That's a chemical process that's been used since the 1800s. So it's well understood, and you can make methane on Mars, and you can use the methane for powering your rockets to go back to Earth, or powering internal combustion engines to allow vehicles or generators to work on the surface. And then also, if you can find water on Mars, you can also make oxygen from the water, and that'll be the air you breathe and the water you drink, and use it for growing plants. So there's everything you need on Mars to survive. And so that's what we believe at the Mars Society, is that this is a great destination for our space program and for the private sector also. Now, one of the big things that we do, we've been around for 25 years. For about 20 of those years, we've operated a couple of research stations. And so the first research station we built was up in the Arctic. And the idea was that if we build a research station, we can show how people can live and work on Mars, and we can show the feasibility of such a mission. And we can also practice all of the human factors challenges that you would have. We're operating with a crew of 4 to 6 or 8 people on Mars, so we can basically make an analog of that here on Earth. You can find a place on Earth that's like Mars, we found this, there was this crater up in Devon Island, Canada, up in the extreme north of Canada within the Arctic Circle. And NASA had actually been going out there for many years with the Hot and Mars project to explore this big impact crater that's up there. And so we decided in 1999 to build this station here, the Flashline Mars Arctic Research Station. And we have sent about 5 or 6 crews there over the years to practice living and working on Mars. They simulate what it would be like to be on Mars for 2 weeks or 3 weeks. But what we found is obviously going up to the Arctic is expensive. It's quite a trek. You basically have to take a couple of airline flights up to Yellowknife in Canada, and then you take another smaller plane to a little village called Resolute, a little hamlet called Resolute. And then from Resolute, which is on a map, you then charter a Twin Otter propeller plane to land on the ice on Devon Island. At Devon Island, we have a site there where this station is, and there's a couple of airstrips there that are just ice airstrips. And so basically, that's how we get to the station. But we figured that's kind of expensive. Could we have a site that's a little closer to home that we can send more crews to? And that we found in Utah, in southern Utah. So if you've ever been to Moab, Utah, this is our site there that you're seeing here is near that. This is the Mars Desert Research Station. It's near the town of Hanksville. And we've been operating this facility since 2002. And we've had 1,500 crew members stay here, over 280 individual crews. One of those crews was in 2005, a young woman by the name of Jessica Watkins was on that crew. And she later went on to work on the Mars rovers. And then she became an astronaut at NASA, and she just flew to the International Space Station and just returned last month, was up there for 6 months. She was the first Black woman to stay at the space station long term. And she's one of the people that may be the first astronauts to go back to the moon. So Jessica Watkins, she very well could be the first woman to walk on the moon in the next few years. And she's in the pipeline at NASA to do that. So I'm very excited about her success, and also all the other folks that have stayed at our station and gone on to do awesome things in the research community and business community and elsewhere. So Jessica and one other person, Cyan Proctor, are 2 of our alumni that have actually gone to space, but they're not the first. They're only the first 2, I'm sure. We've operated this facility I mentioned for 20 years. I actually got to go on a mission in 2018. So here's my crew. It's crew 197. And there's some of my good friends. One of them was my wife's best friend growing up, Sasha Greer. You can see her in the bottom right of the photo there, wearing the JPL hat that she borrowed from me. But this was a really fun mission. We got to stay at the station. It was part of a project I was running to do virtual reality. And I'll talk about that a little bit. But we stayed at the station and pretended to live on Mars, and we could see the spacesuits we're wearing. They're simulated spacesuits. They feel like a real spacesuit. It's a helmet and backpack, and there's kind of blows air so that you feel like you're breathing like oxygen on Mars, and you're not getting too hot in that suit. But it's a lot of fun to do a mission like this. I kind of compare it to going on a scuba diving trip where you're gonna go scuba diving every day for like 4 or 5 days. It kind of feels like that. You kind of wake up and then you have breakfast with everyone, talk about what you're going to do that day. And then you gear up, you put all your gear on, you go outside, and it's kind of like heavy backpacking. You go around the hills and look for samples, or look for biological samples or geological samples, or go to different places and look at the canyons and things like that. We did some stuff where we flew a drone while we had the spacesuits on to kind of practice that. And then you come back into the building and you take all your gear off, and you're all sweaty and exhausted, and you kind of rest, and then you write reports that night about what you did, like record all your logs and your data. And then the next day you do it all again for like 10 days. That's what it was like. And it was a lot of fun.
Interesting. And I suppose it gives you a lot of insight into not only what might have been possible or might still be possible to be possible on Mars, but what astronauts have done uh, all these years.
That's true. Although one of the reasons why we do this program is to show NASA the benefits of an exploration approach. It's surprising to people. A lot of the research that NASA does to prepare for long duration space missions is all about medical effects of zero gravity. Like when you have astronauts floating up in the space station for months at a time, there's bone loss and muscle loss. That's why you always see them exercising up there. We actually at the Mars Society, we don't think that that's the right approach for NASA to take, because you could actually give people artificial gravity on the way to Mars, and then they'll have real gravity on Mars. It's not the same as Earth. It's about 1/3 of the Earth, but still that would eliminate a lot of this zero gravity health effects.
Yeah,
Also,
when I've looked at things, that seems to be one of the primary elements that is mentioned in any of the, Wikipedia or news articles, is concern about weightlessness. But to you,
right.
that's not a major hurdle.
It's not. It's if you have the crew acclimated to Mars gravity on the way there, by spinning their spacecraft, or having a spacecraft that's designed to have artificial gravity because it has elements of it that spin. Then you're not going to have to deal with zero gravity health effects. And then what you could also do is on your way back to Earth, you spin it up and get people acclimated to Earth gravity before they get back to Earth.
What's interesting to me about that, James, is when I went into Peace Corps, I went from the United States climate into the Pacific Island climate, which was highly the humidity was much higher than I was used to, so much so that almost takes your breath away. And the whole idea for the first week essentially was to get us acclimatized to that. And so what you're talking about, and by the time we were there for 10 days, whatever, we were fine. With it, never complaining about all the hot and the humidity. We never did. But it was interesting, and coming back exactly the opposite. So it was really, what you're saying is so true.
Yeah, thanks. So yeah, this was a fun mission. Here's me kind of geared up as an astronaut, and I also one of the things I did while I was there was I had this little experiment that had a small computer that was mounted on the wall that helped the crew understand like what the weather was and other elements of their mission. But this was a lot of fun. This also, once I did this once I did this mission, it led me into working more with virtual reality. And so now at the Mars Society, we actually have a virtual version of our station in Utah that you can visit in virtual reality. So this is great for events and like museums and going to schools, because I can show what it's like for someone to walk on Mars by just putting a virtual reality headset on them, and they can visit our station in Utah, walk around the Mars base, and it really feels like they're there. And so we've had a lot of fun with doing this project, and it's also been a great way to train people that are going to go out to Utah, to kind of give them a little bit of a preview of where things are and what the procedures are to be an astronaut at our station. So this has been a fun project. We also we have a lot of other programs at the Mars Society. We do some educational programs. So this is one example. This is our University Rover Challenge competition. So this is designed for university students. They'll form teams and they'll build a Mars rover of their own design. And they're quite large. You see some of these examples here. And then they'll bring it out to Utah, and we have this whole competition where people will take the rover through a bunch of different challenges. Like they'll go through an obstacle course, they'll try to do autonomous navigation of the rover, have it drive, like essentially self-drive itself to different places, look for science objectives. And so this has been a great experience for a lot of students around the world over the last 10 years, 15 years that we've been doing this program. Every year we have this and a lot of these teams come out to Utah and compete with their rover designs. And I actually got to be a judge at this last June when we did it, the competition this year. So this was a lot of fun, and one of the examples of an educational program we run. Another example is this program here. We just started this program last summer. The idea here is that we're going to give a bunch of high schoolers an opportunity to learn engineering concepts by having them do a competition to design a Mars mission. So we did this for the first time. We had 40 students from around the world, all over Zoom. And it was a 6-week program. The first 2 weeks, they got lectures from a bunch of experts about Mars, like some of the people that work at JPL on the rovers and scientists that work on looking for water on Mars. Other folks that were interesting, like Homer Hickam was one of the speakers, and you may remember the book Rocket Boys, which was a New York Times bestseller, and there was a movie called October Sky that was made in the late 90s with Jake Gyllenhaal as playing him. But he's a real guy. He lived in West Virginia, grew up there in the 50s, and learned how to make model rockets with his friends, and won a National Science Fair medal, and met Wernher von Braun, and went on to work at NASA. And he worked at NASA throughout the 80s on the space station program and the shuttle program. So he spoke to our students. So they had all these lectures for the first 2 weeks, and then we organized them into teams based on where they lived in the world. And they had teams of 6 to 8 students, and they designed a Mars mission, like where we told them you can go anywhere on Mars, you can land 30 metric tons of people and cargo, a crew of like at least 4 people. Where would you go, and what would you do, and what would your habitat look like, and what are your science objectives, and what would you try to look for? So there was 5 different teams, and all 5 of them turned in a report that was 10 pages long, and they did a presentation on it. So we had them present for 30 minutes, and then the next day each team got 30 minutes to critique the other team's designs. And then the third day they had 30 minutes to respond to all the critiques. And this was an extremely successful experience, a positive experience for these students. We just saw a lot of them at our conference last month, and we're definitely going to do this program again. And it showed the value of, if you challenge high schoolers and have them do advanced engineering concepts, they can do it. They can do it. They can do research on their own, and they can learn these things if you just give them a little bit of a push and give them the tools they need and some help. They can do amazing things.
Yeah, I can also see that it's a real world issue, so they could see some of their ideas influence the future. I mean, they're advancing the thinking.
Exactly. I mean, there was a couple of ideas that they had that I thought were very good ideas that I'd never heard before. So it was really awesome to see that. So yeah, so that's one of the things we do. Another thing we do, we have an annual conference every year, and we just had it last month. It was at Arizona State University this year, and it was very successful. We had 400 people in person. We had about 5,000 people watching online, and we had 150 different talks. We had the CEO of Rocket Lab, Peter Beck from New Zealand, zoomed in and talked to everyone. We had the person that's the deputy administrator at NASA, so the number 2 person at NASA, Pam Melroy, who is I think she's an American legend, American hero. She was a test pilot in the Air Force. She flew in Desert Storm. She was a space shuttle astronaut and flew the space shuttle, and now she's the NASA deputy administrator. Could go on to be the first woman administrator of NASA in the future as well. And so she spoke at our conference. We had folks from around the world. We had a team from Mongolia come and speak. There was 10 people that came, and they're planning a station kind of like ours out in the Gobi Desert in their country, and we're partnering with them on that. So there's a lot of really interest around the world. in Mars, and people from around the world that are interested in it. Having our conference every year is a great way for them to connect with each other. But we weren't able to do that in person during COVID back in 2020. Everybody was trying to figure out what to do because of the pandemic, and Dr. Robert Zubrin, who's our president, who's my boss, he turned to me and said, we should just do our same conference, all 4 days, 100 talks. Let's just do all that online. Like everyone can join us online, and it'll be like a huge event, big space conference. No one's ever done that before online. So like,
you swallowed very and thought, oh my gosh, I'm going to do this.
Yeah. So, and then he so he said all that in front of like 5 people, and then he turned to me and said, James, how do we do that? And I said, well, I think we're going to need to get Zoom, and we're probably going to need some other piece of software to tie all the 100 different Zoom calls together. People can like log into like a lobby and like pick the talks they want. And so we found this software to do that. It's called Attendify. And I set up 100 plus Zoom calls and Zoom webinars, and we did it. We pulled it off. It was a 4-day conference, and we had 10,000 attendees. And we had, for speakers, we asked for all the people we would ever want to talk at our conference. Usually we ask like people like Elon Musk, and they turn us down. But that year,
right, they're not going to travel to your conference.
Yeah. Well, this time they did. He zoomed in. So did the NASA administrator Jim Bridenstine. Also spoke. You see him down at the bottom photo on the Zoom call. So it was a great experience, and very successful. We got everything happened on Zoom, and it was a little touch and go sometimes. I was running a lot of it on my laptop at home, So when we were having, that was literally the Zoom call with Elon there, you see, where he's in the Tesla factory in California, and Robert's in his office in Colorado, and I'm in my office in Sammamish, Washington, and it's all running off my laptop, and there's 1,900 people on the Zoom call, and another, however many tens of thousands watching on the live stream. It was kind of crazy. There's 400 questions on the Q&A panel, and it was my job to pick which ones Elon was going to ask.
You look remarkably calm in that picture, given what possibly going on in your head.
Yeah, I kept it together, but it was a lot. But that was fun, and we did it again last year of 2021, and then this year we were back in person at Arizona State. But we still have the online component too. So yeah, those are fun events. And then the last slide I have is just we have this other project called Marspedia. It might be interesting for you folks. If you have some spare time and wanted to volunteer on something, we have this online encyclopedia, and we always need help maintaining it. It's kind of like Wikipedia. It's called Marspedia. It's kind of the same idea as you have this encyclopedia that people volunteer to help out with and edit the articles and add new content and keep up to date. So we've been doing this for about, I'd say 8 years now, and it's gone really well. So yeah, that's another one you can check out. But yeah, that's kind of what I wanted to talk about today. There's my contact info.
Yeah, I was going to say, if somebody is interested in volunteering or learning more, just email you. Is that?
Yeah, they can email me, and we have lots of different volunteer opportunities. Right now we just did our conference. We use a lot of volunteers to put the conference on. We had about 30 people help out with the conference, both virtually and in person in Arizona State. But we're about to do a workshop at JPL or NASA Ames in the spring. So we're starting to plan that out, how we're going to put that workshop on. We have chapters around the world. We have a chapter in Seattle. We have a chapter in, several in Texas and a couple in California. And around the world, we have them in Europe and Asia and Africa. So right now we're looking for folks that can help coordinate all the different chapters and make sure that they have what they need to be successful and go out in their communities and talk. Another thing we have is this thing called the Ambassador Program that we just started. So this is where we're going to train people to kind of talk about humans to Mars, kind of like the talk I'm giving right now. Go out to Rotary clubs and different community organizations and talk about what we do at the Mars Society and why going to Mars is a good thing for humanity and for the United States. So that's another thing people could, if you're interested, just reach out to me, and we can see which plug you into some of our volunteer opportunities. Or if
Great.
you just want to talk about Mars to me.
Well, that's given the breadth and depth of the organization. That's very generous of you to be willing to offer your time.
Yeah, and I actually have it set up well. I can meet with anybody. They can schedule a meeting with me using a tool in my email signature. And so I talk to all kinds of folks, people that are interested in the Mars Society, people that just have questions about the feasibility of going to Mars or different things. So yeah, always happy to talk to whomever about this.
Yeah, it seems as though with the advent of a number of these private space companies, you mentioned Musk, but Bezos and others, that the opportunity to try to explore a Mars mission has opened up because of the idea that you're not dependent necessarily on governments alone.
That's true. Let me talk a little bit, because we've had involvement with both of those two billionaires you mentioned. So Elon, we've known Elon for a while. He actually was on our board before he started SpaceX. And famously, my boss, Robert Zubrin, tried to talk him out of starting a rocket company back in 2003 or 4, because Robert had just seen another billionaire named Andrew Beale in the 90s start an aerospace company to build basically a small space shuttle that was be reusable, and burned through all his money and failed. And he didn't want Elon to do the same thing. But the difference between Elon Musk and Andrew Beale is Elon Musk taught himself rocket science and has an unchallenged work ethic. I mean, I wouldn't even call it a work ethic. The guy just works himself silly.
Yeah, well, I'm sure people may have suggested that the idea of purchasing a social media company might not have been wise either. So,
yeah, that was a topic of conversation at our conference for sure. A lot of us feel like he's getting a little distracted right now with Twitter and all that. But yeah, back in the day, he was one of us before he was as famous as he is now. And he actually helped us start the Utah project, the Utah station. He gave us a small donation. Well, I say small, it was $100,000. But that helped us get it going back then in 2002. And then Jeff Bezos has his company is called Blue Origin, as you guys probably know. And Blue Origin has a nonprofit wing called Club for the Future. And last year, Club for the Future gave 19 $1 million grants to different space organizations. And we were one of those 19. We got $1 million from Club for the Future. And that actually allowed the Mars Society to open up the position I work in now, the executive director role. So I'm the first full-time executive director. Before that, I was a volunteer, and other folks were volunteers in that role. But yeah, so we actually have connections to both Jeff and Elon. And although Jeff is not really a Mars guy, we know that he's more of a space colonies in Earth orbit kind of guy, and maybe the moon a little bit. But he definitely wants to see a large space community that's thriving, and so he included us with those other 18 organizations, which we're very thankful he did.
Yeah, and it sounds like also you have connections with folks in other countries. You were talking a little bit about the Gobi Desert and so forth.
That's right. We have chapters in most countries. We have a chapter in China and France, India. We have chapters in Kenya, Ghana, South Africa, Singapore. Just name a big country, and we probably have a few people there trying to do the Humans to Mars advocacy with our logo. And a lot of those people I know personally, and it's a great group of people. Mostly folks that are, technical fields like engineers and teachers and professors and scientists, But we really welcome anyone to be in the Mars Society. We're a big tent. You know, we want to have people from all over the world, all different backgrounds, helping us out. So.
And it seems like it's a combination of advocacy and maybe some information, learning, and research.
Yeah, we do a little bit of private research on our own. Our research stations, typically the theme is human factors, but an individual crews will come and do their own research projects. Our virtual reality effort is a research project as well. We're trying to gather data on training crews and other elements of operating our station. But yeah, it's definitely advocacy and educating people. I mean, just trying to get the general public interested more in space. I mean, when I talk to people at NASA, like real astronauts and things, like folks that are that are trying to make this future that we're talking about a reality, I ask them how can we help the best, and it's all about just educating people about the possibilities, talking to the general public about human exploration of the moon and Mars and getting them excited about it. And the fun, if more people are interested in that, then the funding will come. The public funding will come, and the private sector interest will come. And we're already seeing that. If you compare what things are like now with how they were when we got started 25 years ago, it's a huge difference. I mean, now it's mainstream that most people, if you ask someone on the street, is it possible for human beings to go travel to Mars? I mean, they would say yes. And a lot of people think we've already done it. Not just the conspiracy crowd, the secret government alien crowd, but people just think, oh yeah, we've gone to the moon. I'm sure we've gone to Mars too. That just makes sense because we're able to do things like that. But they don't realize that it hasn't happened yet. It's a little harder, but it's possible, and we advocate, for us doing it within this decade.
And when you look at things that are of value, you mentioned the idea of rare earths and the idea of resources that might be available. Also, does it reflect back on ways that we might be able to treat this planet better?
Yeah, I think I mentioned if we can understand why Mars got the way it got, how it lost its magnetic field, and how it lost its atmosphere. Also, Venus, like why is Venus basically has a runaway greenhouse effect? It's a very hot, sulfur heavy atmosphere. Earth could get that way if we're not careful. And so by studying these other planets, we're also studying how planets work and how the Earth works, and deepening our understanding of the Earth, and hopefully in ways that we can help the situation with climate change.